Hi, I'm Steph, and today's learning objective is learn about hydrocarbons, how they are formed, and how they've been converted into crude oil. This is topic 2.5, part A. The basics of hydrocarbons. Hydrocarbons can be made using crude oils, and hydrocarbons are often just compounds that contain hydrogen and carbon atoms only. Crude oils are often formed by the remains of dead organisms that got buried for millions of years. And it's also a finite resource that's found within the Earth's crust and is a mixture of complex hydrocarbons. Crude oil has lots of uses, and these come from fractional distillation of crude oil, and they can produce lots of different things such as fuels, which can include petrol, diesel, kerosene, and so on. Also, lubricants can be made by using crude oils. You can also make some solvents and detergents, and the list goes on. The learning objectives for the next few slides is what is fractional distillation and how it is applied. This is for section 2.5 part B. Fractional distillation. The basics of fractional distillation is that crude oil is heated and boiled so that it can be separated into its different layers of hydrocarbons. These are called fractions. These are dependent on the length of chain at which point it will cool off and be used as different types of fuel such as diesel for cars, or longer chains like bitumen for roads. As you could guess, there are lots of applications of crude oils, as it can produce lots of different types of fuels, which can be used in lots of different scenarios, such as kerosene, which is a good petrol for planes, and bitumen, which is used as tar for roads. Hi, I'm Steph, and the learning objective for this next few slides is how the size of hydrocarbons affect the boiling point. This is topic 2.5, part C. The effect of the length of hydrocarbon. The longer the hydrocarbon's chains, the higher the boiling point, and therefore the lower down it ends up inside the fractional column as it becomes a liquid lower down the column. The increase in boiling point is caused by an increase into the molecular forces of attraction between the larger length hydrocarbons. Hi, I'm Steph, and the LO for today of this next few slides is how does the chain length affect the properties of crude oil and how they can be applied. This is for topic 2.5, part D. Properties of crude oil. The smaller the molecule, the more volatile and flammable, but less viscous the molecule will be. However, the larger the molecule, the less volatile and flammable, but more viscous it will end up being. Fuels can have multiple different applications, such as kerosene within planes and diesel within cars. However, they're all chosen due to certain properties which they all have. So an example would be bitumen would be a horrible fuel for cars, as it's very viscous and is the least flammable. And this means it wouldn't easily flow into the tank and possibly be difficult to ignite within the engine. However, due to its high viscosity, it's good for sticking bits of gravel together and small bits of rock, and therefore is good for making roads, as it's also very durable and lasts for a long time. Hi, I'm Steph, and the next few slides are on the importance of industry and its impact on the environment. The oil industry has a huge economic importance. The price of crude oil is controlled by oil companies and therefore have a huge control over the global economy. Countries that produce these crude oils have also increased political power due to being able to stop supplying other countries over any political disagreements they have. These countries can also have political crisis or wars, and these can also lower the oil supply and affect the entire global economy. However, crude oils also have a huge environmental impact. So burning these crude oils as a fuel releases CO2, which is a harmful greenhouse gas. And this releases it into the atmosphere and is one of the main causes of global warming. Another problem is also oil spills. These also harm the local environment severely and are costly and lengthy to clean up and can often be ignored in poorer areas of the earth. Hi, I'm Steph, and the learning objective is what is combustion and how reactions vary with different fuels. This is for 2.5 Part F. What is combustion? Combustion is an exothermic chemical process of burning a fuel with oxygen and usually releasing heat and waste. In the case of hydrocarbons, the equation will often look like this, where a hydrocarbon is burned with oxygen present, releasing CO2 into the air and water. These reactions can vary with fuel, and different fuels release different amounts of energy. Therefore, some fuels have better energy content than others, meaning it could be a more efficient fuel. This will be calculated using calorimetry within the next slides. Hi, I'm Steph, and the learning objective is how to calculate energy released by a fuel, as part 2.5, part G. This is how to do calorimetry. You'd use the setup on the right, and you need to measure the mass of the water at the start to ensure it's a fair test. You'd also need to use the same starting temperature of the water and the same increase of temperature within the water, as well as keeping the same distance from the flame from the calorimeter, sorry. And to actually start recording the temperature of the water at the start, then you'd heat the water with your fuel within the spirit burner. Record the final temperature once you're done, and also measure the change in mass of the fuel before and after. As you can see, the setup is quite simple. All you need is a thermometer, some water, a calorimeter, and a spirit burner. As you can see now, this is the equation you use to link up everything from the previous slide on calorimetry. So Q is the heat transferred in joules, M is the mass of the water in grams, C is the specific heat capacity of water, which you can just search up, and T would just be the change within temperature. So the learning objective is how hydrogen fuel is different to other fuels and its pros and cons. So per part 2.5, part H. The benefits of hydrogen as a fuel is hydrogen fuel could be renewable, depending on whether they manufacture it using the electrolysis of water. It is also known to have a high fuel efficiency. The current problems, however, is these aren't able to be done efficiently at the moment and cost effectively. However, the bigger problem is that it's also mostly hydrogen is mostly obtained using hydrocarbons, which is not exactly the best for the environment, and is also very difficult to store, difficult to transport, and also highly explosive, which isn't useful in the car, as if there's an accident or a crash, it's quite easily, or quite likely, sorry, that there will be an explosion due to the hydrogen compressing and then obviously exploding itself.